Hello again, Bearcats. It is time for some AP review. Today's subject matter will be 2017 AP test, and we're going to talk about FRQ number 3, which you can see over here. Is a pretty straightforward area under the curve problem. So hopefully you spent some time on this one. Hopefully you experienced some success. It's pretty straightforward, follows the lines of the other ones. They're going to give you a value, and then you're going to have to count forward or backwards from that value to figure out where you end up. So this is the thing that relates. Do you understand that the integral is the area under the curve? Do you understand that the integral of f prime is just f? Because if you understand that, then you should be pretty successful. You also have to understand that if this is the f prime graph, then the derivative of this graph, which is the slope of this graph, at each point is going to be the second derivative. So those are the big key factors that you have to know. So in this problem, it's going to start with some information. It's going to give you the data from all the way from 6 to 5. And it's going to say, hey, at negative 2, it's worth 7. So what it's saying is, if this was my starting point right here, that f of negative 2 is worth 7. Now I know that it's totally not differentiable at that point. Well, no, sorry, it has a derivative of 0 at that point. However, I know that that's the value of the original function at negative 2. So if I count in this direction, all of these areas that I count, I'm going to add to it. So this would be a negative area, and a positive area. And if I count backwards, then that area, which should be positive because it's backwards, is going to be negative. So I'm going to need to know what the area is of all of these shapes. So this triangle right here is 1, 2, 3, 4 by 2. So it's 1/2 of 4 times 2. So this triangle has an area of 4. This here is pi r squared divided by 4. So it's 1/4 of a pi r squared. So the radius is 2. So 1/4 of pi 2 squared. This is going to be worth a pi. This is worth a pi. And this is a triangle that's 2 by 3 divided by 2. So 2 times 3 is 6 divided by 2 is going to be 3. So those are my areas, and I'm going to be using those, I think, in this first part of the problem to get my total answers. So let's take a look at what they have for their results. Okay, so when I take this away, this diagram is going to disappear, but we can make sure it magically reappears somehow, some way. So there we go. So you can see for the first problem, it's going to ask for, hey, how do I find the area? By the way, I'm making magic happen right now. It's called folding documents. All right, so it's asking me to find these values. So the first one says, hey, find f of negative 6. Well, if I want to find f of negative 6, then I'm going to have to start here at negative 2 and count backwards until I get to 6. So I'm going to start at what it's worth at negative 2. So remember, it's worth 7. So I'm going to start with 7, and then I'm going to add everything from negative 2 to negative 6. So I'm going to start at 7, and then I'm going to add, notice how it flipped it and went subtract. So I'm going to start with 7, and then I'm going to subtract the 4 because I'm going backwards. So that's why it says 7 minus 4, and I get a total of 3. So you get a point if you use the initial condition of 7, and if you find f of negative 6, you get that. If I'm going all the way from 2 all the way to 5, well, I'm going to add a negative pi, another negative pi, and a 3. So that's 7 minus 2 pi's and 3. It's 10 minus 2 pi. They did write it as the integral, so you might want to include that integral. The point at negative 2 plus the integral from negative 2 to 5. The area under the curve of f prime from negative 2 to 5. All right. Part B, question B says, I got to unfold this. This is pretty cool. Fun with folding, ladies and gentlemen. If I was cool and digital, all this stuff would be magically on my computer, but I'm not. All right, here we go. Part B says, on what intervals is this increasing? So I have to find the intervals when this is increasing. Well, isn't this just a graph of f prime? So isn't this increasing when f prime is greater than 0? So what are the intervals where f prime is greater than 0? Well, anything that's above the y-axis is at f prime. If this is the graph of f prime, all of these have f prime bigger than zeros. So what are my integrals? I have to go from here to there, and I have to go from there to there. All of those are intervals that are bigger than f prime. So let's see what they wrote. Sure enough, there it is. There are my two intervals, everything from -6 to 2. So everything from the -6 to 2, -2, and everything from 2 to 5. That's it. Oh, justification, sorry. Since f prime of x is greater than 0, that's the intervals where it happens. So it did ask for justification in the question. All right, part C. Part C is going to ask us for some absolute value, absolute minimums or absolute maximums. So remember, for absolute minimums or absolute maximums, we have to check endpoints, and we have to check critical values. So if we have a table that has all the endpoints and all the critical values, all we have to do is plug it in. So if I'm going all the way from -6 to 5, well, that means here's my first endpoint and here's my second endpoint. So my table is going to have those 2 points in them. So I'm going to have to check x equals -6, x equals 5. Now any critical points, remember, critical points occur when the derivative is 0, and I know it's a maximum or minimum if I go from increasing to decreasing. If the f prime graph crosses 0, then f prime goes from positive to negative or from negative to positive. So you can see there's a value here and there's a value here where that happens. So I'm also going to have to check -2 and +2. So those are the 4 values that should be in my table. So let's take a look at how they wrote it up. So here it is. It has -2 and 2, 5 and -6. So I'm going to plug all of these values, and the way they got these values here is they just went, hey, what's f of -6? I think we did that in the first problem. We got 3. Hey, what's f of -2? Hey, that was the given piece of information in the beginning. That was worth 7. Plus we did 5. That's f of 5. We got that one already. It was 10 minus 2 pi. We would have to go back to our graph and calculate 2. But 2 was just everything except that final little triangle. So f of 2 is going to be 7 minus 2 pi. So I have to find the minimum value. So I have to figure out which one of these is the smallest possible number. So remember, pi is approximately 3.14. So this answer here is going to be like 7 minus about 6 something. So this is going to be like 0.8-ish, right? And then this one here is clearly bigger than 0.8-ish because it's 3 more. It's going to be like 3.8-ish. So this right here, out of 3 and 7.8, that is clearly the smallest number. So it says the absolute minimum value is 7 minus 2 pi. Okay? Cool. All right, last part. Last part asks us to find. It says for each of f double prime at -5 and f prime at 3, find the value and explain why it does not exist. Oh, or explain why it does not exist. So I'm supposed to find the derivative of this derivative at 5. So that means right here, that's -5, and right here, that's 3. So I need to find these two derivatives and state why, what they are or why they don't exist. So this one's super easy. It's sitting right on a line. I should be able to find the slope of that. Line goes down 3, or down 2 and over 1, 2, 3, 4. So that slope is going to be -1/2. So the derivative is -1/2. This one here, no slope because it's a corner. And remember, corners aren't differentiable because the slope going in, the limit as I go to 3 from this side does not equal the limit as I go to 3 from that side. The slope as I go from this side does not equal the slope as I go from that side, so it does not exist. So here are there are two values. So if you found the second derivative, that was the slope. We said it was -1/2. That's worth the point. If you stated that f double prime does not exist with explanation, So I like the way they did this. They said from the left side and from the right side, right? So here's the left, here's the right, and then this is 2, and this is -1, so these two things are not the same. So if you state all of this, to some extent, it doesn't have to be exactly like that, but I would say limit as it approaches 3 from the minus side, limit as it approaches 3 from the positive side, and I would include those two slopes, and then state they're not the same. So, all right, hopefully you did well on that one. If not, try it again and go back over it again. All right, catch you next time.